So today we're going to talk about pool pumping. And you better believe it, if a home has a pool, pumping water is going to be one of that home's largest energy expenses. Now, why is that? Well, water has a lot of mass to it. So moving water takes a ton of energy. Typically, it's anywhere between 30 and 70% of a home's energy use. And although most people know that getting a variable speed pool pump is a hack, they don't necessarily know why. And so there's this super magical, amazing secret we're going to reveal for you today about how to save a massive amount of money with your variable speed pool pump. So without any further ado, what is this super magical secret? And what it is that the speed in which you pump water makes an enormous difference. Now, not to get too nerdy on you, but there's something called the law of affinity. And the law of affinity is a flow dynamics law that says the power requirement varies by the cube of the change in speed. So what does that all mean? Well, it means that when you pump water at 1/2 the speed, you use 1/8 the energy. I'll say that one more time. When you pump water at 1/2 the speed, you use 1/8 the energy. So let's see how this plays out with a typical pool pump in a day of filtering. Imagine the pool pump is moving water at 3,450 RPMs. That's 66 gallons per minute. And what you'll notice is when you're moving water at that kind of speed, at that kind of high velocity, you're going to get more back pressure. You're going to get kind of resistance in the pipes. It's called head in plumbing speak, and that resistance makes the pump work harder and use more energy. Now in this case, you did pump water quickly. It only took 4 hours to completely turn over the water, replacing the existing water in the pool with new, fresh, filtered water. But let's look at another example. Imagine this pool pumps water at a lower speed. It's only operating at 1,800 revolutions per minute. And so what you'll notice immediately is that there's less back pressure, there's less head, there's less resistance in the pipe that make the pump work harder. And so we're only moving half as many gallons per minute, and what we have to do is we have to run that pump longer. In this case, 8 hours to turn over the same amount of water because we're only pushing half as much water. Now, this pump uses 2,000 watts of electricity to operate at 3,450 RPM. The pump below that pump uses only 250 watts. So even though it runs longer, it's using 1/8 the energy. Let's see how this all plays out when we compare these side by side. So let's do the math. Old pump, 2,000 watts for 4 hours. New pump, 250 watts for 8 hours. So that old pump is gonna basically use 8,000 watt hours per day. That's 2,000 watts times 4 hours. While the new pump is only gonna use 2,000 watt hours per day. That's only 250 watts times 8 hours, twice the time, but 1/8 the energy. And so ends up using about 1/4 the energy to move the same amount of water. It's like a magic trick, right? So if this pump pumped using 8 kilowatt hours a day, every day of the year, they would use 2,920 kilowatt hours per year, while over here, they would use only 730 kilowatt hours per year at 30 cents per kilowatt hour. This pump, this old pump, or the pump, even if it was variable speed that was operating at full velocity, would cost $876 per year to run, while this pump over here would only cost $219 per year to run, which equates to about a $657 annual savings. And if a variable speed pool pump costs a couple $1,000s to install, the return on investment ends up being about 3 years. That's a 33% return on investment. And it's a 33% return on investment after tax. What does that mean? Well, if I got 33% ROI on an investment in, say, the stock market, I would have to pay capital gains on that and would only see a 26% ROI based on my tax bracket. But because this is a straight tax-free return on investment, meaning this is an actual savings and the government can't tax your savings, this is a after-tax ROI, which makes it a phenomenal return on investment. depending of course on your specific situation. So there are a few takeaways that I want you to kind of have your mind blown on today. The first is, if you are currently using a low horsepower pump, you might not qualify for this upgrade. Meaning, if I'm only pumping a 3/4 horsepower pump, I might not be able to reduce the RPM that much. I might not be able to reduce the output that much. But if it's anything greater than 3/4 of a horsepower, 1 horsepower, 1.5 horsepower, and I'm pumping that thing at full speed, or I have a variable speed pool pump already that's pumping at a high velocity, what I'm gonna wanna do is I'm gonna want to pump the water slower and for longer. And even though I'm using energy for more time, I'm using so much less power, right? The peak power, the draw is so much lower, 1/8 if you're running the pump at half the speed, I can run that pump for much longer and have significant savings. Now there's a few other disclosures I want to leave you with. These are, say, warnings as you kind of embark on your pool pump energy savings initiative. The first is that there's a difference between filtering and cleaning. So today we talked mostly about pool pumping for filtering. There are some pool pumps that do require high levels of flow, high pressures to clean because they run the cleaning head. Now, if you're in that situation, you can still save significant money by operating your pool pump, implementing the law of affinity. What would you do? Well, for the cleaning cycle, which may only be an hour or an hour and a half or 2 hours, you can run the pump at that higher speed, and then you can drop down to a lower speed for filtering for a longer period. And so that's kind of a way around that if you don't have a robotic cleaner, if you have a pump-driven cleaner. The second important requirement is that if you're heating your water with solar pool heating, that requires a kind of a high pumping velocity to get that water up to maybe a second-story roof, you may need to run your pool at a pool pump at a higher velocity, while maybe in the wintertime when you're not using that solar pool heating, you'll still have an opportunity to save. So that's something to keep in mind as you kind of embark on this journey. Now, the third really important thing is beware of that pool guy. Now, there are a lot of great pool guys out there, but they're not paying your energy bill. Their primary concern is keeping that pool clean. So when you go to them and say, look, I'd like to run the pump a little bit lower, they may say, no, you don't want to do that. It'll turn your pool green. Kind of, work with them, work in partnership with them, create some alliance with them. Say, look, I really just saw this amazing YouTube video. It blew my mind. If I run this pool pump at half the speed, I'll use 1/8 the energy. Even if I run it for twice as long, I'll use only 1/4 the energy. If they're sharp, they'll be like, oh yeah, that's true, and they'll probably figure out some kind of solution. They've never heard of that. Their mind may be blown too. You can send them this link. But ultimately, you want to kind of find a compromise. And one of the ways to do that is to start incrementally. Maybe you're not cutting down the speed in half. Maybe you're only reducing it by 10 or 15% and running it a little bit longer to start, and make sure that the pool's not growing algae. It's not a lot harder for the pool guy or yourself if you do pool maintenance to clean. So you can kind of incrementally reduce that speed and extend that run time to get as far as you can down the journey of saving energy. Okay, so I'm now going to transition to show you a calculator that you can basically get for free through my website that I built, consulting with originally a formula from some reputable pool pump manufacturers, so that you can get an estimate for your own pool in terms of how much money this will really save you based on your specific scenario. So we're going to jump into kind of that mode, and you can take a look at that. And if you want to click the link below in the description below, that'll allow you to access that free calculator. So thanks so much for joining me. If you haven't already subscribed to this channel, I got a ton more home energy content that's going to help you achieve your energy efficiency, saving money, your comfort goals all year round. Potentially, if you want to go solar and storage, it'll give you insights on how to do that in the most effective way. And any other electrification goals, including converting from gas vehicles to electric vehicles, all of that is going to be on the channel with real actionable math that you can use to achieve these upgrades in your own home. Otherwise, let's jump into the calculator. I'll show you how that works, and I hope to see you in a future video. Okay, I'm now in the pool pump calculator. I'm gonna walk you through exactly how it works and how I'd use the tool if I was doing the calculations for either a customer or my own home. So we're gonna start off with the basics. Typically, what you will pay per kilowatt hour for electricity In California, this could be as high as 30 or 35 cents per kilowatt hour. Maybe if you're Midwest, it might be lower, like 15 cents or even as low as 10 cents per kilowatt hour. It's going to depend specifically on your utility and what you pay for electricity. So start with a reasonable number based on your bill. If you need to do that math, you're basically going to take your annual electricity costs, right, your dollars, and you're going to divide it by your annual kilowatt hour usage for the whole year, and that'll give you a good starting estimate. It doesn't do interval data, meaning every 15 minutes or every hour what they charge you for, but this will give you a good back of the envelope start to figure out your savings. The second data point is going to be the size of your pool. This is important because if you have a very large pool, then you're going to need to pump the water for a longer amount of time at a higher gallons per minute to get the pool to turn over once in a day. And that usually is the minimum goal to filter water, at least 1 turn per day. And then you're going to find the existing horsepower for your existing pool pump. If you go to your nameplate, you can typically see something like HP, and this is a specific, it's called service factor. I would just focus on HP as the data point. And you'll see in this case, it's 2.5. Pentair is a pretty popular pool pump, so I just am showing some examples. In this case, the horsepower is 1 horsepower. And you'll see this on the outside of your pool pump typically, and you're going to enter that data point as well. Oh, by the way, for pool pipe size gallons, if you don't know the amount of gallons your pool has, it's got a pretty simple calculation. You're going to take the width of the pool times the length of the pool, or if it's a circle, you'd have to use some basic geometry and multiply it by the depth. And once you have the volume, the number of cubic feet, you'll know that you have about 7.5 gallons in each cubic foot. So if you have, a 10,000 cubic foot pool, you'd have 75,000 gallons. So there's 7.5 gallons about in each cubic feet. Okay, now that we've entered those first kind of 3 data points, we're gonna update the tool with how many hours you typically run your pump per day. And if you're running it, say, at a low number of hours, you might find that the turns per day are less than 1. And so the main thing that's really important is that the turns per day in this calculation are consistent for your existing pool pump and your new pool pump. Because if you're getting more value by running the pool pump in a way that allows it to turn the water more frequently, then you're going to probably be using more energy, and vice versa. So I would recommend truing this up to about 1 turn per day as a starting point. And if you're running the pool pump less than this calculator shows you, depending on your gallons and your horsepower for your pump, you may not be turning over your pool frequently enough. But I'll leave that to you and your pool expert to discuss. Once you have that normalized to about 1 turn per day, it's going to show you about, based on this horsepower pump, whatever you have chosen, and those many hours and that many gallons, about how many kilowatt hours used per day, and then to multiply that number by 365 and by the cost per kilowatt hour to get you your annual pool pumping cost. In this case, it's $1,700 per year, $1,736. And then here's where the magic really happens. You're going to enter your new pool pump information. And the new pool pump information is based on a standard high quality variable speed or variable flow pool pump. And where the magic happens, as we discussed in the first part of the video, is that really as you can control the speed of the pump, you get more value, you get more efficiency. And so what you're going to try to target is a lower RPM. And maybe you're running that lower RPM for many more hours in the day. Maybe I can get it down to, 1,400 RPM. And once I get it down to that lower RPM, I'm going to kind of look and see how many turns am I getting in a day. Well, in this case, I'm not getting enough turns in the day. I need to match the turns. In this case, on this above example, I'm getting 1.1. I drop that down, maybe 1 hour. Well, we'll keep it at 1.1. And I'm only getting 0.87. So maybe I need to run this a little longer or bump the speed up a little bit more so that my turns per day basically matches the turns per day above. And then as I mentioned, in some cases, you need to run the pool pump at a higher RPM to use the cleaner, or maybe if you're pumping the water up to the roof, there might be a period in which you want to run that pool pump at a higher speed, and then for less hours, hopefully. And if you're running it for more hours or a higher RPM, you could probably, in this case, we're up to 1.5 turns, you could drop the low speed hours you'd run. But ideally, you're trying to run this high speed function for 1.5 hours, maybe 2 hours at the max, and trying to run this low speed a little bit longer, maybe 8, 10, even 12 hours if you can. And once you match those turns per day, it's going to show you that before you were pulling about 16 kilowatt hours per day, and now you're only pulling almost 8, so about half. And the kilowatt hour savings is about 8.6 per day, and that makes the savings per year almost $900. So even if that pool pump cost, $2,500 or $3,000 fully installed, your return on investment is still going to be 30%, which is a phenomenal ROI as a after-tax ROI. I think I talked about that in the main video. So, if you don't need any high-speed operation, you can drop that down and maybe run this a little bit longer, as long as you get that kind of equivalent turns per day. And you'll again get some insight into how much money you can save based on that low-speed operation that's available with a variable speed pool pump. So feel free to play with the calculator. If you want to save the state of the calculator, you can click this copy URL, and it'll create a distinct link that you can put back in the URL, and that'll kind of give you access to the existing settings and the existing values that you had entered into the calculator. Okay, quick disclaimer here. Results may vary, right? Depending on your home and your home's unique characteristics, your pool pump's unique characteristics, your pool's unique characteristics, you may or may not save as much as, 4x efficiency, or reduce your cost by 3/4 or $200 a month. That being said, there are significant savings to gain here. And if you want to see, in what scenario is that even 4x thing that you're talking about true? Well, if you didn't have to run a cleaning pump at high speed, and you can go all the way to 0 on high speed, maybe you use a robot that's electronically kind of powered, and you could really extend that runtime out 13 hours or 14 hours at a lower speed, you may have started with as high as 20 kilowatt hours per day and reduced by, in this case, 15 kilowatt hours a day. So it is totally possible. And the phenomenon of using 1/8 the power when you pump water at half the speed is the law of affinity and true, something I learned from physics, not something I made up. It's just how it applies in your specific home that is going to have all the impact and going to vary based on your specific home. So I wanted to make sure that disclaimer was clear. Results may vary, but go for it. You have a real opportunity to save on one of the largest loads in your home and have a significant impact on your energy costs. Now, if I didn't say it already, that impact can be used in so many different ways, right? You can just save money. If, for example, you want to electrify something in the future, maybe you wanted to convert from a gasoline vehicle to an electric vehicle. Now you have additional kilowatt hours that you were spending on pool pumping that you can now allocate towards the use of an electric vehicle. If you were about to buy a solar system and you were going to size your system based on this pool pump that was inefficient, now all of a sudden you have less energy use. You can size a smaller solar system, a smaller battery system. That can save significantly in upfront costs. So there's a lot of flexibility and benefits in exploring and discovering efficiency opportunities before you electrify and solar. Even if you do that stuff first, having that strategy and plan in place really does make a difference. So have fun with it, see what you can accomplish. So one more really cool quick story to tell you. About 10 years ago, I was working with a homeowner who had me do an energy audit, and I, looked at all their upgrades and their appliances and their pool pump and asked them about their pool pump and said, you have a brand new, very nice pool pump. They'd kind of overpaid for it. They spent about $4,000 on the pool pump, and this was a long time ago. And I said, well, how are you running the pool pump? Are you running it for, how many hours a day and at what speed? And she says, I think I'm just running it for 4 hours a day and, at full speed. And so I gave her the same guidance I gave during this video. And so she made a change to the pumping speed and time. She reduced the speed and extended the time. And before we had even done any projects, I think we're gonna do solar on her home and other projects, she called me the next month and said, I just reduced my energy cost $200 per month without any other changes. Now she had about a $500 or $600 bill per month, so that was a very significant reduction, and it cost her virtually nothing to make that change. And so that gives you a really good example of how impactful this change can be if you can implement it in your home. I hope you save a ton of money, get a ton of value. Anyways, I hope you love this video. If you haven't already subscribed to the channel, I encourage you to do that. Lots of more exciting home energy content on the way. Have a great rest of the day. I'll see you in our next video.